Okay, in this video we're going to understand what it means to model a sheet metal part. Now if you're used to working in any CAD package like Autodesk Inventor, you will mostly be modeling in solid parts. What this means is that you create a solid component and you take cuts and shells and various different features out of a solid material. Now working with sheet metal as a physical material in industry is very different from solid modeling. And modeling in a sheet metal part in Autodesk Inventor is very different. For example, as you can see from the environment that we have in front of us, if we look along the ribbon, the first thing you'll notice is that the tools for modeling are very different. So whereas before we'd have extrusions and we'd have shells and various different features that a solid part would facilitate, here all the component choices and all the modeling choices that we have are to do with sheet materials. So we always start with a face. We then add a feature called a flange, which is a bend onto the side. As with solid modeling, if you hover over any of the components or any of the tools, they will preview for you what they're going to do. So for example, a typical bend will feature there, and it will tell you exactly what those two things will do. And as you can see, for example, the punch tool is a very classic one in terms of working with sheet material, in that you actually punch through using a tool the sheet material to kind of punch the shape out, much like a cookie cutter would work. So if we look at this component here, this is a randomly dimensioned component to look like a VEX part. And the way in which it's been built, the way in which it's been assembled, as you can see down the left hand side on this tree, pretty much tells a typical story about how a sheet component is manufactured. So we've started with a face, and as you can see previewed in the modeling area here, we start with basically a blank piece. We then add the flanges onto both sides, and that makes the typical bend of the VEX C channel. The cut is effectively punched out a square hole, and what we've done is we've just rounded those corners just on the inside to kind of match the detailing of a VEX component. We then pattern that along the edge, and then we've mirrored it onto the other side. We've then repeated the process of cutting onto the top surface and then creating that matching corresponding pattern. Now most of the component features that we've seen are very typical of sheet material. The ones like mirror and typically a cut could be applied to a solid part. But when you actually work with sheet material in the Autodesk Inventor environment, there's a few things that obviously are naturally very, very different. For example, if you look under here, under Modify, Unfold, if I click Unfold and click a component and then an edge to unfold, what you'll see is that I can actually unbend the virtual model of the component into a flat sheet. If I repeat that process again, unfold along that edge, and click OK, I'm now back to where the stock sheet of material has been created. So this is a really good way of kind of undoing effectively a 3D sheet virtual net along all its bend lines. And this is really typically how you can see how you're going to actually manufacture these using a plasma cutter or a laser cutter or any various different process that you have available to you. My stock material will arrive like this without all the little holes in it. It will be plasma cut, all the little holes will be cut in, and then of course it will go around, and using my own processing tools I will then be able to bend and form this component into the VEX component parts. So now the next video to look at is how to actually model up a VEX EDR component.